Hello, good evening to everyone. We are going to wait for a couple of minutes and we are going to start after that. This is the quarterly product updates webinar for Q4 2022. And we have some great stuff coming for this webinar. So yeah, we're going to wait for another minute. Okay, so we're going to start now. Right, so this is the index for today's presentation. We have about 8 different topics we are going to speak about. They are going to be separated by months. So October, November, December, right? So we're going to start with October, and so I would say it's the major release of the quarter pretty much, which was the release of the partial structures feature. So we have been working on this feature for about 6 or 8 months internally. It was a very complicated feature for us to develop because of all the changes we had to make in the calculation model. But I would say that the results are great, and we are very happy with the quality that this gives to the designs that pdesign makes. I'm going to show you really quickly how it works. So I have this design here, which has it's not too complicated, but it has some complexity in it due to the perimeter of the terrain of the site. And the feature, you enable it by coming to the equipment tab. In the structure subsection, you go to partial structures and you select a number of strings per structure. So what this does is that this allows you to use shorter structures in the design. So for example, in this design, I have a very long tracker. It's the NX Horizon with 90 modules. And if I want to fit more power in the PV plant, I can use shorter structures like this by choosing to have structures with 2 strings instead of 3. And if I refresh here, we will get a higher peak power value. So we have 17 megawatts, now we have 22. And it's also noticeable in the fill factor of the PV plant in that we have many more structures, right? So yeah, it's a very important feature to get the power up and to bring the design closer to what you would expect from a real life engineering study. Back to the presentation. The next feature, it's we already designed some pages and we made other improvements in the software. So we are always looking at ways to improve the user experience and improve how pdesign looks and feels. In this particular release, we changed how the projects page looks so that it's more compact and you can see more projects at the same time in the page. And we did another change, which I also find really useful, which was a change to the map layers. So if you clone a design, or well, you start a design from scratch, and you are sitting at the design process page. Let's wait for it to load. There we go. So I don't know if you've noticed it, because you have this button here for layers. And what this allows you to do is to show different parts of the layout and hiding them. So we can hide the available areas and reset the areas. And the change we made was that you can now separately hide the structures due to the rejection cost. So for example, we can have a look only at the structures rejected because of the undulation tolerance limit. So this one here, you can see that the colors match the colors of the layers, so that you know it's the same one. You can also see the rejections due to the slope limit. So it's really easy to find parts of the layout which have problems due to particular reasons, right? Like slope limits or ondulation tolerance. And I will also point out that you can change the background, let's say, of the map using this button here, which is also really useful. And well, there are some options there which can help you visualize this map more easily. Yeah. And finally, there were also some changes to the company page, where the way we show the license is now a bit different. We are looking at ways to making it easier to understand what the license is and how many projects you have left and all of that. So moving on to November. In November, the first release, the first new feature was the automatic CapEx templates. So the CapEx feature has been challenging for us from the beginning because it requires a lot of work from your part in you need to set all the values for the different entries, right? You need to set the price for each one of them, and it's a lot of work, really. If you need to, especially if you want to have a highly detailed CapEx estimate, right? So what we wanted to do was we wanted to make it easier for everyone to have the CapEx estimation and the LCOE. And the way we did that was that we took the prices from the IRENA studies for a number of countries. And when you create a design from scratch, you will automatically get the IRENA template for that country. So let me show you how that works. If I go to PV design, I'm going to get into this project in the USA. And just without imagining that I have no designs here whatsoever. So I click Start Design. And now, while this loads, I will go to the Costs tab. And here you can see that the United States IRENA 2021 template is automatically selected. So all the values are already set. And what this means is that without having to do anything, I will automatically get a CapEx estimation for my PV plant and the LCOE as well. So it's not the most accurate CapEx estimation ever, but it's really, it fits PV design really well in that it's really fast and easy to have it. You don't have to do anything to use this feature. And like I said earlier, there are templates for many other countries in here as well. And well, as part of this feature, we also remade the template selector here, which is now much easier to use, and it has a better organization. So yeah, hopefully this will make it easier for you to evaluate the quality of your designs, and especially also having the LCOE as well within PV design without having to do anything. We believe it's really valuable. Right, so moving on, we had other improvements as well in November. So it is now possible to upload metadata files, CSV files in the Vaisala format. It's right there in the dropdown. You will be able to select it. And we also made some other visual changes to the features in the design process, like the windows that pop up when you are uploading a topography file or creating a new site, and also the tables that you use to select the photovoltaic modules and inverters. And we also remade those, and they are now more similar to the rest of the interface, really. Yeah. So moving on to December. December was packed of features, really. I think that coming to the end of the quarter it came to a situation where everyone was rushing to finish their developments and release them to the software. So we had a lot of releases this month. The first one was the improved power distribution. So this requires explanation. Power distribution is the name of the algorithm we have inside PV design, which creates the electrical configuration and distributes the DC equipment in the inverters that it needs to use, right? So in other words, it's a part of the software responsible for the DC-AC ratio and the design of the power stations and the inverters. The thing is that the previous algorithm, it was likely to, in some situations, it could create a design where there were a wide range of DC-AC ratios in a PV plant. So you could have inverters with DC-AC ratios of 0.9, 1.1, 1.2, 1.4, and it was there was too much variation, right? So we wanted to narrow that down as much as possible, and we also wanted to give you the possibility of defining the range yourself. So you can do that now. if we go to, let's say, this one. So if you go to the layout tab and you go to power requirements, you can select here the lower and upper limit. This is for the maximum capacity mode, by the way. So you define the lower limit and the upper limit. And what this means is that this is the target for the algorithm. So this is the desired DC-AC ratio value for the design. And these are the minimum and maximum values that you accept for the inverters and, of course, the power stations. And it's not immediately evident what this does, but I can show you where you can see it. And I think that the easiest way to have a look at it, well, you can look at the SLDs, of course, so the low voltage single line diagram. But you can also look at the design report. This is one I'm going to download now. So let's see, yeah. If you scroll down to the, I think it's over here. So the inverters, yeah. String combiner box, central inverter, there. So these are the, well, it looks like the table got cut in this document, but you can see here that we have two kinds of inverters, one with this ratio and the other one with this one. So in this case, it's, I mean, the software was able to it was very accurate in getting the exact DC-AC ratio that we wanted, which was 1.25, I think. So it balanced between these two options. But in previous designs, you may have a situation where you had a lot of a lot of variation, where you may have like 10 different kinds of inverters, right? And that was undesirable. So we wanted to simplify that as much as possible. And the new version does that really well. So yeah, moving on. Yeah, I think that's it. You will also notice that the power stations are much more balanced as well, because the inverters are more balanced, right? So moving on, more substation settings. PV Design has a fully fledged substation calculation model, which sizes the substation, chooses equipment, and does a very detailed design. But we have very few options in the interface to tweak how the calculation model works and to customize the results, right? So we are going to change that in the future. The first step towards that is to include these three new options that you have here, which are to select the power transformer type. So you can choose between 2-winding and 3-winding. You can size the transformers manually if you want, by either capacity or the number of bays. And you can also manually change the number of output bays in your substation. So let me show you that in the interface. If we go to this design, so in order to use these options, you go to the grid point tab, which is here, and you go to connection type, and all the options are in this particular part of the interface. So you have the power transformer type option in here. We also have the option to size it manually. You may get some warnings here if the sizing algorithm determines that there could be some problems with the values you choose. And you can also choose here to size by the number of transformer bays. And you can also change the number of bays manually. And you will see all of these changes reflected in the documentation for the substation, which I will show you right now. So you go here to all documentation, you scroll down, and you can find here the drawings, for example, the interconnection facility report. So in this case, I will open the interconnection facility single line diagram in PDF. And well, for this design, the only change I made was to have a 3-winding power transformer, which you can see right here. But any change you make to the design will be reflected in these documents. So next, the next feature was the improved earthworks platforms feature. So this one, it's a bit complicated as well. What we were looking to do here was to improve the quality of our earthworks design. Over the past year, we have found that the feature we released initially, it had the characteristic that it was underestimating consistently the volume of earthworks it needed to do. The reasons for that were many, but really they can be summarized as saying that it was too optimal, in the sense that it did individual platforms for each structure, which was, well, for one thing, it's a bit unrealistic, but also it leads to a situation where each platform fits the terrain really well, and so the estimation is really low, right? So the change we made was that now the structures which require earthworks will be merged together into larger platforms. We will also include in these platforms any surrounding structures which are either improving the shape of the platform, right, or they are in holes in the middle. And we are also including structures which may have been rejected. So, for example, if you have a situation where there is a platform with structures in the middle which were rejected due to other topography characteristics such as slope, they will be included in the bigger platform. That results in higher peak power. But the main goal was to improve the quality of the estimation for the cut and fill volume, right, for the cubic meters. And I can show you what that looks like. So if I go over here, I have this design, this one. So there is no change in the interface, no immediate change. So the filters are still the same. The way the feature works is still the same. But now you will notice that if you zoom in, you can see some lines in between the structures. And if I use the layers feature from earlier, I can disable all the layers. And now you can see that there are these let's see, earthworks platforms, that it is. So these platforms are this is the boundary of each platform that there is in the PV plant, right? So all of these ones have structures with earthworks in them. And you can see that we try to make the shapes as regular as possible, and they are also large in the sense that they will envelop many structures if they are adjacent. And if we look at the layout 3D for this design, I think it's an interesting document because of how easily it is to visualize what the algorithm is doing, right? So let's see there. And we also made many improvements to this document, but let me show you what the platforms look like. There we go. So now you can see that the yellow areas are the earthworks platform. So if I zoom in, we can see here what these platforms look like. Now, the borders between the platforms and the terrain are vertical walls, and that's an issue that we were not able to fix in this release, but hopefully in the future we can improve it. But yeah, this should result in a better estimation for the cut and fill cubic meters, so you can better estimate the capex and other economical analysis. So finally, we released 2 new languages for the documentation, Japanese and German. I will show you how those look in a moment. And we also released the overhead line documentation in 3 new languages, which is Portuguese, Chinese, and Italian. So let me show you the documents in Japanese now. I think I have them right here. So let's let this load. There we go. So if you go over here and you click the language code you want to download, so in this case I will download Japanese, and I will download the design report in Japanese, which is this one, right? And well, it's the design report in Japanese. I don't have much to say. I can't speak Japanese, but I think it looks great. But we also have the documents in German as well. So those are these ones. And I'm going to open a different document this time. Let's say I will open the layout in PDF as well. And for example, in the drawings, you will find the changes in the, oh, sorry, I didn't change the language. So in German, there we go. German PDF layout, let's go. Now, yeah, you will notice that the legend over here and the notes, now everything is in German, right? And also all the translation inside the documents in the energy report and all of those, you will also find all those results in the language you download, right? So for example, the energy report, you can find the table of losses in German here. So, well, that's it for the releases for this quarter. I think it was a great quarter in terms of the features we released. Partial structures, we were really excited about that one. It took many months and it was a great release. Also, the substation inputs, I believe it's really a game changer for people using the substation feature, which is great because it's such a complicated calculation model, and it's great to give it, to make it more powerful, right, for our users. So yeah, at this point, I'm going to answer some questions. I think I already have some here. So the first one, it says, is there an option to make the medium voltage cables visible, similar to what you were showing with the other features? Right, I assume you mean in the design process. So in design process, in this view that we have in here, the medium voltage system and the medium voltage cables haven't been calculated yet, not in this view, let's say. And so the calculation model for that hasn't run yet, and so this is all that is available. The structures and the topography filters and the areas. If you want to see the medium voltage cables, you need to run the full design. So you do that by clicking generate design over here. You click this one, you run the complete simulation. And when it finishes, you can load the complete design in here. And this one does have the medium voltage system. So we can see it right here. Let's see, I'm going to disable everything so we can have a look at it. There we go. So these are the medium voltage cables connecting the power stations in red. Right, so it's just a matter of running the full simulation in order to see them. Right. Can I add a layer to a sitemap? For example, I want to know the approximate noise level of inverters and substation transformer and the appropriate dB level at our fence. Well, okay. The answer is no. I'm sorry about that. That isn't a possibility yet. However, I will make sure to relay this request to our product management team, because it is an interesting feature for sure. I assume it's related to the environmental analysis for the PV plant, right? So that's really interesting. Thank you. Then comment regarding transformer bay definition. I have not heard of a transformer bay, so I assume that means a feeder bay on the bus in the substation. Transformer bay, a feeder bay on the MV bus. That's a really technical question. I'm not an expert on the substation calculation model. What I can do is I can relay you to our blog post. We have some information there regarding the substation design. And I can also say, and this is best if you relay the question to our customer success team, and they can answer you directly. This is probably something you can, if you are a PV design user, you can probably check this on your own by looking at the interconnection facility SLD. So that was this document here, right? And I imagine that what you are asking is answered in this document. But like I said, I am not an expert in the substation, so I can't answer that question directly, I'm sorry. Right. Hello, regarding the transformer, will it be possible in future to insert directly the MVA value desired instead of have a choice the one suggested by the program in the drop menu? Thanks. That's an excellent question. I would have to ask the owner for this feature, but my guess would be no, probably not. Because usually we have some problems where there are steps of possible values, right? And the reasons for that are related to sizing. So you can have any particular transformer size you want, right? It has to be a specific value for sizing reasons. So yeah, that's at least what usually happens in this situation. But same as before, I will relay the request to our product management team. And also as well, I would say this is also a good opportunity to ask them directly, send an email to customer success and get an answer from them, because if we didn't add the option to have the manual input, right? If we didn't add the option for you to design, to define that value manually, there were probably some good reasons for it, is what I mean. So yeah, still, I hope there are enough options for your designs. So yeah, if this is an issue, please let them know. Perhaps also there is a situation where there is a difference in standards or something like that, which is affecting this value. Okay, so MV lines connecting parcel to each other and to the substation, right? So I think that this refers to the possibility of defining how do the MV lines connect areas. In order to show you that, I'm going to go to a design where I have more than a single area, which it's maybe not so easy to find. This one, oh, this one does, but it's really short. So let's see if this one is better. No. Let's see, this one's the same. I'm going to try one more and then I'm going to go back to the other one. Let's see. It's taking a bit to load. Okay, it's fine. So I will show you how to do that. So when you are in the design process page, you can go to this location tab, right? And I'm going to go straight into the interactive site creation tool, which I'm going to do by cloning this one, right? And well, there seems like there is a very long overhead line here, but for this demonstration, I'm just going to draw an available area, like so, and I'm going to define the road's access point. And so the question was regarding how can I manually define the connections in between the areas for the medium voltage system. So the way to do that is to go to path, and here we have three options: MV cable, shortcuts, and overhead lines. I'm going to choose MV cable. So this way I can define the path that the medium voltage line should follow from one area to the next, like so. And I'm going to do the same for the other area. Maybe something a bit ridiculous, but just for an example, right? And I'm going to save as new site. Let's say MV cables, like so. And now when I run the simulation, I will get the medium voltage system following those lines I just defined. So this is a way to customize your design and make sure that you are respecting features which PVDesign isn't aware of. So for example, you may have a situation where there is a complicated topography feature in between the areas that you want to avoid. You want the MV cables to avoid that, right? And the way to do that is by using this feature. Right, let's see. Can you define or change the locations of the power stations? Right, excellent question. The answer is you can't do that manually. The reason for that is that PVDesign depends on it's an automation algorithm, right? So it looks to find ways to do things automatically in the most optimal manner. If you were to manually change where the power stations are, that will require recalculating everything after the change, and that's really complicated to do in terms of software, and it could also end up breaking the design, right? So instead, what we do is we give you a lot of options to give PVDesign hints regarding how you want the power stations to be positioned. So for example, you can go to the power station tab, and there are some options here regarding if you want the power station to be outside the AC field. So this option is the power station located by the road, and inside the DC field, it's well, like the picture shows, it's embedded within the structures, right? And you can also change the roads, and this will lead to changes in the position of the power stations. But yeah, regarding the possibility of manually selecting the position of the power stations, that's something that we want to do in the future and that we have been looking at for a long time. It's a very requested feature. But like I said, we have problems with it because it kind of goes against the other objectives of the PVDesign software, the other objectives for the development and how the software is designed. So it's going to be a complicated feature, which I honestly don't know if when we are going to release it, or even if we are going to release it at some point. So yeah, like I said, we are looking into it, but it's a very long development. All right, so I don't have any more questions. I'll give you a few seconds to drop another question if you want, but if not, we are going to end here. Okay, so I think there are no more questions. In that case, we're going to finish here. Thank you so much for assisting, and thank you for your questions. I'm sorry I couldn't answer the very detailed substation questions. Please write an email to our customer success team. They will be happy to answer your questions in a very high level of detail. So thank you again, and have a nice day.